So if you have a matrix that looks like this, and you're supposed to fill in what you can find for the variable specifically and how it gets to these answers, you have to remember that it's column times row, row times column every time that you're working with a matrix. So the way that this works is this entire column is your x values. So you can rewrite this as a system as x, 2x, and 3x. The middle part here would be y, minus y, and plus 2y. And then the third one here would be plus z, plus 2z, and minus 1z. And then what they're equal to is already out here, 3, 6, and 13. And you can solve using a combination of substitution, elimination, anything like that. If you combine these first two, then it'll cut you down. You'll already have 4x plus 3y is equal to 16, because the z's will cancel each other out. And then you can multiply this entire one by 2 and make it cancel with this one. So that'd be 6, 7, 8x, and then 4 minus 1 would be plus 3y, and then this would be 2z, so those would cancel out. That'd be 26 plus 6 would be 32. Then subtract, subtract, subtract. In this case, you end up with 4x is equal to 16, so x is 4. And then from there, if you have to find any other of these, you just start putting it back in. Y in this case would actually end up being 0. And since you know x is 4 and y is 0, you go back up here to the original one, z would be negative 1. You can also do take the c times the inverse of a if you've entered the matrices in the calculator and find it that way. But I like to work with numbers where I can see what I'm doing the whole way through, and this would be the way to do it.